So welcome everybody to the security stream. Very good morning to you. My name's Jamie Pease. I know most of you know me. I'm the chair of the security working group and the chair of this stream for the conference. So this is session 1AZ, and it gives me great pleasure to welcome Mark Wilson, who's by no means a stranger to the security stream. I think you were once chair, weren't you, and technical coordinator of this very working group.
I think I've worn every single hat possible.
You've done every single hat
in
GSE, so now he's our region manager and conference manager and everything else that he does for GSE. So really interested to hear about this next session. As we know, the systems programmer play a very valuable role in all things disaster recovery, including security. Isn't that right, Mark?
Yes, and that's what we're going to be talking about.
Okay, over to you, sir. Thank you.
Thank you, Jamie, and good morning. And thanks for having me, Jamie, and the security working group. As it says here, Mark Wilson. I now work for a company called BMC Software, and what we're going to have a chat about is the role of the modern day systems programmer, because I think the modern day systems programmer today in 2021 is a little different to what it was when I first started doing this role a number of years ago. So got a little bit of an agenda here that we will run through, to talk about the role, talk about what I think's missing, have a look at what's going on in the real world, and also what does it mean to us. And what I mean by that is, you know, perhaps we need to start thinking about a change of attitude and a change of thought process. And then literally my thoughts on the role of a modern day sysprog is really summed up in two or three charts. I'm quite happy to take questions as we go through this. If you pop them in the chat window, I'm sure Jamie or Sue will moderate them and interrupt me as we go along. If not, we can have a Q&A session right at the end. For anybody out there who doesn't know me, I've probably spoken to the majority or presented to the majority over the years. I've been a mainframer since 1980. I started in May 1980 in a very similar role to what you see in that little black and white picture there, 3420 tape drives, real 3420 tapes. And when the developers or the systems programmers or the batch job said, I want data that's not held on a real spinning disk, it's on tape, the message would pop up on the console. We'd walk over to that tape library where there could be 2,000, 5,000 or 20,000 or more tapes. You'd manually pick it out, you'd walk over to the drive. Of course, we don't do any of that now. It's mainly 99.999% all virtual tape. So you roll forward to today and you roll forward to sort of 2021 and you, sorry, press the wrong button. Oh God, you see our world now on these shiny new Z15s or Z15s as we Brits would say. And a lot of it's virtual and a lot of it's replicated. And that in itself poses somewhat of a challenge for us. We're going to come on to that. You may be wondering why there's a grey British battleship on the left-hand side of this presentation. I was never destined for a career in mainframes. I was going in the British Navy. I'd been accepted and I needed something to do for 6 months. And I ended up working at an engineering company in the West Midlands called GKN. And I went there and I did a training scheme for 3.5 months. And I ended up being there for 3.5 years. And here I am 40 plus years later. So I'm very much a mainframer, and mainframe security is one of my specialist subjects. But I'm also a systems programmer, or I was a systems programmer. So I went through what back in the day you could consider the traditional route: operator, senior operator, shift leader, ops support, systems programmer. And now really my role is all about writing PowerPoint presentations, managing my inbox and Excel spreadsheets. Very rarely do I get to log on to a real mainframe and do any real work. But if you look at where the mainframe sits in most large corporations who run this technology, Yeah. It's the system of record. Sometimes it's the system of engagement. But what we can absolutely say is ZOS and the mainframe runs the economy of the world. We've all seen the numbers. Yeah, X number of airlines, X number of insurers, X number of banks, X number of Fortune 500 clients all run mainframe. You walk down the high street in any developed economy and you look at all the financial institutions, they run a mainframe, they run a mainframe. The large retailers run a mainframe. Yeah, the large insurers, they run a mainframe. Core to running that mainframe is the role of the systems programmer. And I don't get asked so much today as I used to back in my earlier days. My friends and my family would say, Mark, well, what do you do, Mark? Well, I'm a systems programmer. What does that actually mean? When somebody says, yeah, I am a systems programmer, what does it mean? So I actually Googled it and went and had a look, and I found a document there from an IBM website, and it says, yeah, this is what a mainframe systems programmer does. They install, customize, and maintain the operating system, or install or upgrade products that run on the system. You can get them in different forms. You can get an upgrade, you can get a brand new install, so on and so forth. You drill down a little bit further, and there's a little bit more here. It talks about planning for hardware, training the operators and application programmers. Don't do so much of that these days, but looking at automation, capacity planning, running those install jobs, doing the customization, doing the integration testing, and doing that system-wide performance and capacity tuning. That's what the documentation says. Yes, we do all of that. But what you quite often find is, especially in some of the manuals, here's the error message, here's the problem. If you can't work this out, contact your systems programmer. Because to me, this is what a systems programmer does. Yeah, they solve problems. This is what we are. We are problem solvers. We get given business challenges. We get given technical challenges. Yeah. It might be, Mark, yeah, we have a 2-hour outage every week to perform this housekeeping or IP other systems. Can we get rid of it? How do you architect the solution, the systems, the software, the hardware to solve that problem? That's what we do. I really do like this image, and one day I am going to get around to making some of these hoodies and bring them to GSE when we get back together next year and we have that in-person event, because we will be back. Then I'm going to get some of these made. But you know, we solve problems. But if you look at all of this and you look at what it says on the IBM website, and if you go and search the job adverts and look for mainframe systems programming roles, there are things today that are missing, in my honest opinion. And you kind of just have to say, well, what is missing? Yeah, you look at all this, I'm going to install stuff, I'm going to customize stuff. At no point is there any mention about the mainframe systems programmer being involved in security. And security is a very, very wide subject. It's not just, well, how do I configure RACF ACF2 top secret, or how do I configure KICS or DB2 to take advantages of the services of the ESM RACF ACF2 or KICS. It doesn't talk about disaster recovery. And more importantly, today in 2021, and we're going to cover this in a little bit more detail later, it doesn't talk about cyber resiliency. And we are going to have a conversation about that. And there are other things that are missing that are really important, like being a champion for the platform, to be able to go and communicate to the C-levels the value that this platform brings to a business. Because more often than not, yeah, we're a bunch of techies. There's one of the team who has a delightful turn of phrase. She's an Irish lady in the team, and she says, yeah, we're all just pointy-headed nerds who dream and think in noughts and ones. Yes, a lot of systems programmers are like that, but we've got to up level our game to be able to be involved in the conversations around security and cyber resiliency, and why traditional DR is really not what we need going forward. And we'll come on to that in a little bit more detail. I've often professed, and a lot of people have heard me say this before, yeah, the mainframe, in my honest opinion, and many others, is the most securable platform there is on the planet today. We have more tools and more skills and the ability to make this thing absolutely rock solid. But it takes investment, it takes time, and it takes people to take ownership. And that's a word I'm going to use a couple of times through this presentation, ownership. And it's not ownership to say, yeah, I'm the systems programmer, this is my system, go away, you're not touching it. I'm not talking about that kind of ownership. I'm talking about owning the problem and going and working to resolve the challenges we've got in and around the security of and the recoverability in some cases of these systems. And you might think to yourself, well, why? Well, certainly, there's a lot of people on this call I've known for many years, and it's been a really interesting change for me over the years to see the mainframe, the hardware, the software develop over the years. If you look back where we were in the 70s and 80s, and even to a point in the 90s, the mainframe was that isolated, in the data center, behind locked doors. If you wanted to get to it, you'd got to have a pass, you'd got to be escorted by the security officer, and you went in, sometimes it was in a cage. But more importantly, when you connected to that mainframe, you knew where the people were. Back in my days at GKN in the early 80s, if we had a new starter, we would come in on a Saturday morning and go and lay a coax cable. We'd plug it into the back of a controller. We'd run the coax through the ceiling, down the wall, probably a patch socket, and a fly lead then from the patch socket into the back of the real terminal. Click. It had a 8-character LU name. It was defined to the software. We kept documentation that says this LU is in office number 3 on the 3rd floor, desk number 10. We knew physically where it was. That's what it was like back then. So there's a lot of reliance on physical security, but it's not like that anymore. We've got more and more APIs and connections and everything going on the mainframe than we've ever had before. Open this, connect this, connect that. How many ports do we have running on the mainframe? Running at TCP/IP that are listening for connections. Do you truly know? Have you got a handle on all of that? Somebody needs to understand it. IBM have done some great work with technology like ZERT to allow us to understand what's going on. How many of us actually have taken the time to go and look at it? And this is what I mean, take ownership. I wonder if we've got a problem. Don't wait until you have a problem and then try and solve the problem. So get ahead of the game. Start looking at this stuff now. And the reason we need to be like that is there is a lot going on in the world. And I don't know how well you can see the graphic with all these sort of lines running all over the globe, but there is literally data flying all over the place, everywhere. From our even from our little office here in Bromsgrove, we're connecting to systems all over the world. The big organizations, the large banks, the large retailers, connecting with suppliers, connecting with their remote offices. The remote offices connecting to remote office and head office. There's data flying everywhere. And that is something that the bad actors really understand. And this is big business for them. There's a lot of money at stake. But we as mainframers have quite often said, don't worry about it. Nobody understands what we do. Nobody gets it. Who knows how to log on to TSO? Who knows what KICS is? Nobody, the hackers, the pen testers, they don't really understand it. Well, that's not true, okay? Because there's a tremendous amount going on. If you just Google it and you end up at Git, you end up at one of these little repositories. It's called Awesome Mainframe Hacking. And this is regularly updated. Simple Google search, bang, straight away. If you scroll down on this Git repository, you see some of the stuff that's out there. They've got enumeration scripts for TSO, brute force tips for KICS. And this is not just tips, this is actual code, Python. written to absolutely attack a mainframe. They've got a RACF database parser here. We all know John the Ripper, with some work that's been done by people we all know in the mainframe security space, allows you to take the data, if you can copy a RACF database and download it and pass it into John the Ripper and actually brute force attack a mainframe security, a RACF database and the passwords. Now, if you've gone KDF, yeah, obviously it takes a lot more than that. But how many people have actually done that? Has everybody done it? Don't know. They've also taken some of the standard pen testing tools, things like Metasploit, and actually integrated some of the code here. So a non-mainframe pen tester with his Metasploit laptop, so he's got his Kali Linux laptop with Metasploit installed and the ZOS tools that are here on this website integrated in Metasploit. He can simply go to his Metasploit command line and say, I'm working on a mainframe, here's some information, press enter, and it will start firing stuff at the mainframe. It will do things like Nmap, it will try FTP, it will try SSH, it will try kicks, it will try all of these different things because they're interested in it. And we've talked about this a lot in the past. If it is that system of record, the data that sits on the mainframe has value. Yeah, we've talked about this in the past. We've talked about the dark web. There's a market for it. If it has value, people will try and steal it. And I look at this stuff and I think, really? Yeah, I know we've got some good techies looking after our mainframe, but we still see major problems. And then I came across this, which was really, it kind of made me stop and pause. IBM announced containers for mainframes. So you can have a IBM ZCX running a Docker environment on this custom Linux hypervisor running atop ZOS. And here we have two folks, Ian Coldwater, who's actually a container expert, and Chad, who many of us know is a bit of a mainframe hacker. The two of them colluded to work on hacking and trying to break a Docker environment running on Z. And they succeeded. They were able to break out of that Docker container and get to traditional ZOS. Okay, so let's not kid ourselves and think people aren't interested in this and people aren't testing this stuff, because they are. This is brand new. Yeah, this was DEF CON early in the year. So the recordings out there, it's quite entertaining because they actually had an audio visual problem and couldn't do it. They had to do the chat cold, almost without any slides, which was quite interesting. But you look at all the references they've got down here. Yeah, they point us at the Redbook site. They point us at the Evil Mainframe Penetration course. Yeah, attacking and defending Kubernetes clusters. So they used all this information, and two experts from two different sides of the IT world coming together to collude to do this. Now, they fed all this stuff back to IBM, thankfully, and IBM will obviously go and remediate as much as this that is technically possible. But it's I paused when I saw this and thought, wow, because if traditionally I've thought about mainframe hacking and mainframe pen testing being the traditional routes in. Well, I'm going to try and get logged onto TSO. I'm going to try and run a batch job. I'm going to try and update an APF authorized library. I'm going to try and do that bit of bit twiddling and flip the RACF special attribute on, or the non-cancel attribute in ACF2, or look at it from a purely mainframe perspective. These folks are moving away from that. They're not looking at the traditional stuff. They're looking more at the stuff that they've grown up with, and we'll talk about this later. And then I was having another conversation with somebody about mainframe hacking, and they said, yeah, Mark, but we've got to start thinking about this slightly differently now. He said, have you seen all the stuff going on LinkedIn? And I said, what do you mean? And basically the scammers have cottoned onto the fact that people may want to change role. may also want to change role because somebody's offering them a significant salary increase. And this is absolutely a mainframe attack. And what happened here is that the scammers targeted the senior systems programmer at an organization. They did all the digging on him, found out where he worked, found out what his role, and spearfished him, dropped him a direct contact on LinkedIn, saying that there's an organization not too far away from where he lives, you know, a commutable opportunity, looking for a senior mainframe systems programmer. We're paying twice what he's possibly earning now. Would he be interested? Now, I love my job, I like what I do, but if somebody's going to offer to pay you twice what you're currently earning to do the same role, I would say, yeah, most people would reply positively and say, yes, I'd be interested in a conversation. So there are a few backwards and forwards, and they'd sent him a job offer, which was a PDF. The PDF had got a payload on it, so he opens it on his work computer. Now, they didn't know what the configuration of his work computer was. They knew there were some vulnerabilities in the operating system of his laptop. They didn't know if they were all exploitable, but they managed to exploit a vulnerability on his laptop and dropped in a keylogger. They managed to capture his mainframe user ID and password. They actually logged onto the mainframe. They actually caused some problems, and all because of being targeted via LinkedIn. So that's something we've got to think about. You think about, well, I've got all this information out there. I've got you know, a job market at the moment where, yeah, in a lot of places there aren't enough people to do the roles that are needed. We're all getting that little bit older. So this was quite an interesting way of trying to bring the two together. But they got them. Yeah. Now, it's not clear just how much damage or if any damage they actually caused. But you know, it was certainly a mainframe breach, all perpetrated via a LinkedIn job advert. So you've got to think about all of that. And because of that, we need to start thinking about, yeah, how we perform our backups, how we perform DR, and how prepared are we for a cyber security incident. Okay, and the language that we're starting to see talked about now is called cyber resiliency. So if you look at, you know, what's in place today, if you think about what we have in place for DR, we've probably got our data replicated across 1, 2, 3, sometimes 4 sites. Now, I've stolen a slide from an IBM GDPS presentation, but obviously there are other hardware vendors, Dell being one, that offer these type of replication solutions. Okay, so I just stole one. This is what traditional DR looks like. You've either got a 2-site metro, 2-site global, 3-site or 4-site solutions. But this all relies on us replicating the data. And that's what most of our current DR plans are. Yeah, it's there to respond to a system or physical issue. I've lost a data center, I've lost a DASD subsystem, I can switch. The data's up to date. I've got an RPO that's really, really low, i.e. nothing. I've got very, very low RTO, i.e. minutes. So recovery point, recovery times are all very, very small. And it depends what you do. Yeah. But these things, these solutions are all geared to allow us to recover from a physical situation, not a data cyber driven issue. Because if in that previous story, the bad actor had got onto the system and launched a ransomware attack, or just deleted some data, or just encrypted a few bits and pieces, all of these solutions would have replicated the deletion or the corruption of the data. Let's be honest, that's what encryption does. It destroys the data. The only thing between the data being recoverable and the data being good is, do you have the key? If I've got the key, I can recover the data. If I haven't got the data, it's just corrupted data now. it's scrambled. It's bits and bytes all arranged in the wrong order. No good to man or beast. But if I have the key, I can rearrange everything. So this is where we start talking now about cyber resiliency, and we say, what can we do to protect us in the event of a cyber attack? Because that's very different to a DR issue. Yeah? Cyber resiliency isn't about, oh, I've lost the data center or I've lost a piece of hardware. This is about somebody actually doing something really bad to your data, and how would you recover? We're going to talk in a minute about some of the hardware solutions that are out there. We're also going to talk about the software solutions to help us try and do that early detection. What we haven't got at the moment is all of this pulled together and orchestrated to be able to get to the recovery times and the recovery points that you see from the traditional DR solutions. We're not there yet. So if you bear that in mind, what we start talking about now is, what's going on out there from a hardware and software perspective. Now, I'm no expert in all of the hardware. I know some of the stuff that's going on from a software perspective, but from what research I've done and what I've looked at here is, I'm looking at IBM and Dell EMC from a hardware perspective for, they've got hardware solutions now, we'll talk about in a moment, that allow us to take copies of the data at very, very short intervals. And what that means is, if we do have a problem, instead of relying on data that's been replicated, I'm relying on a snap or a copy of the data, the whole mainframe data estate at a particular time, and taking multiple copies of it. The software out there from people like IBM, KRI, BMC, Maintegrity, that's all about trying to indicate when we've suffered an issue so we know where to recover to. What we're missing at the minute is all of that coming together so we can orchestrate it to say, we've seen the issue, this is where you need to recover to get to the point before the data was destroyed or it was deleted or encrypted. Yeah. So if you look from a hardware perspective, we need kind of, four or five things here. We need that surgical recovery capability to restore all or a portion of the data of what was recovered. Now, when you look at the way these recovery solutions have been built by the hardware vendors, what they're doing is they're copying the data, but it's stored offline to the mainframe. So from a ZOS perspective, I cannot see the data. I can't look at it. I can't see it. I can from the hardware subsystem perspective. And we need to be able to work closely with those offline copies to work out how to do that surgical recovery capability. It is that catastrophic recovery capability, though, the recovery point, the ability to restore all of the data at a consistent point in time. But we need to be able to identify when was the last known good state. And that's the bit that's a bit challenging at the moment. I've got all these backups. I've backed up the data. I've snapped it, copied it, whatever you want to call it. I've taken a copy of it every 15 minutes. And I run an Apple Mac, and it's a little bit like Time Finder. I can scroll back through all of my backups and say, right, I'm going to recover the file to that point. And that was at 3:30 this morning. That's my last known good point. Now, I don't want to be restoring to 3:30 in the morning when it's 10:30, on the real clock, because that's way too much change in the system. So what we need to do is the ability to, identify those indicators of compromise early, so we can say, stop. Okay, we've got a problem. Let's almost freeze everything at a point in time. Stop. Don't let anything get any worse. Copy it. So we've got something we can go and do the forensic on, and then recover the data and the systems back to the point, once we've thwarted the attack. So you've got to think about all of these things. Dell are out there with their cyber data solution, and there's a link here. IBM have got their Z Cyber Vault out there. There's various books out there starting to appear on it. You can go and search all of that. So From a hardware perspective, we're now getting the ability to, to copy the huge amount of data really, really quickly and keep multiple copies of it. But what we really need to do is integrate the software so that we now know when something has gone awry. And there are various different solutions, whether you're looking at the vulnerability scanning stuff from KRI or the FIM from Maintegrity. New Era have got some tools in that space. So have many others. I could have gone on for quite a while. IBM have got obviously all the Z Secure stuff, and BMC have got some, the real-time threat detection stuff that we talk about. There's a new red book that's just come out. I don't know if you can all see it. I've printed it. I am going to go through this thing and read it because it's really important to wrap our heads around what the technology can offer to us, because we do need to start thinking slightly differently about, mainframes and DR and recoverability. And we have to really start talking about cyber resiliency. If I kind of move on here and say, okay, well, what does it really mean for us? And I think it's really important for us to understand the threat that's out there. I still have conversations with people who say, you can't hack a mainframe. Mark, you can't hack a mainframe. It's not hacking if somebody steals somebody's credentials and uses them to steal all the data. That is absolutely hacking, okay? It might be I've done some social engineering, LinkedIn or something else, to steal the senior sysprog's user ID and password. I might have actually stolen the junior sysprog's user ID and password. But because of the access he's got, I've been able to elevate my privileges to that of the senior sysprog. Now, I know most systems programmers in most organizations have probably got way more access provision than they need. And we need to start thinking about, as sysprogs, being responsible adults and saying, actually, do I need all of this access to do my job? Should I move towards my role 8 till 4, 9 till 5, whatever it is? This is the access I need to do to be able to do my job during the day, least privilege. And then use some type of technology, break glass type technology, the solutions out there to do this, where when I'm trying to solve a problem, I need my privileges elevated. Well, I do that through a controlled, authorized and audited mechanism that allows me to gain the privileges I need, solve the problem, and then my privileges are reduced. The same when you're doing a change implementation. I elevate my privileges for the duration of the change. Once the change is over, they're reduced. Least privilege really works for us as sysprogs, because not only does it protect us from being exploited, it protects the business and it protects our systems. So that's where we've got to think about. As I said, I still hear people say, it's a mainframe. They don't understand it. It's a mainframe. They can't hack it. We have to stop burying our head in the sand, because to these bad actors, it's just another computer. It's an IP address that now talks some of their language, because they don't come at this thinking about, okay, APF or security privileges, RACF special operations, ACF2 non-cancel, all of that stuff. They don't come at it thinking like that. They actually come at it thinking about things like Unix system services, because this is what they learn in college. This is what they learn in all of the online pen testing classes. They learn about how to exploit SSH and FTP and USS, and also all the plethora of web servers that we run on our mainframes these days. How many versions of Tomcat have you got running there for all these different bits of software you've got running? And then you add in, well, what about containers? Has anybody actually deployed containers? Does anybody know how to test them? I certainly don't at the moment. I'm doing a metric ton of research on this talk that was given at DEF CON. How do you actually validate the security implementation and the testing of this stuff? Because as we keep bringing new stuff to the mainframe, mean, who remembers the days before TCP/IP? It was all VTAM and 3745s and FEPs. And then they brought us Unix system services, and then TCP/IP, now SSH, FTP, now containers. How many of us, as the senior sysprog, the people in the book that it says go and talk to your sysprog, how many of us have actually stepped up to the plate and said, I am going to learn this because I need to understand it? The problem is it takes time, and we've all got our day job to do. But if we don't do this, we could be seriously compromised. So we have to get involved, and we have to take ownership, because without any of that, we are going to be the big target for these bad actors. Because if we are truly that system of record, then we are going to become that target for them. And I don't want any of the people I work with to be on the front page news of, or even on the BBC in the UK, or any of the national television channels, or any of the national newspapers. I don't want one of the organisations I work with, or anybody who's running a mainframe, on the front page saying, systems disrupted, mainframe hacked, because that's just going to cause us all kinds of trouble. So my real thoughts on the role of that kind of modern day sysprog is actually think like a hacker. Okay, don't look at it and think, well, that's okay. Think like a hacker, but act like an engineer. And I've told this story before about one of the team doing a presentation in a security seminar with a bunch of mainframe systems programmers, and they ran a demo and showed how to exploit some of the traditional stuff. We used SSH, we used FTP, we did a little bit of APF and a little bit of assembler. So some of the newer stuff, some of the more traditional stuff. And one of the sysprogs came over to my guy and said, that system, you built that system for this demo. Obviously, we gave ourselves the privileges, or we relaxed the controls to be able to do that. And the systems programmer said, well, you wouldn't be able to do that on my system because I've got all that locked down. And my colleague turned around and said, but could you do that? Well, of course I can do that. I'm the systems programmer. And my colleague turned around to him and said, what if I were you? What if I am actually you and logged on as you? And the systems programmer said, that's not fair. Do you really think the hackers care? No, they don't. Okay, so think like the bad people, but act like an engineer. And unfortunately, don't trust anybody. The concept of zero trust is absolutely spot on for a mainframe. I don't care if Fred has been the systems programmer, or the chief COBOL developer, or the senior manager for KICS or DB2 or IMS in your organization. You do not know whether they are a good person or a bad person, or what's going on in their life. So do not trust anybody. And if somebody comes to you and says, I want to do this, it's okay to say why. It's okay to challenge. When you get that install manual and it says, if I use RACF as an example, run this started task as trusted, or give this started task UID 0, it's okay to go back to the vendor and say why. Why do we need this? This is not secure. This is not best practice. Go and have that conversation with them, because you never know what's going to happen in somebody's life. People's lives change. You walk into an organization as a tender 21-year-old, you've got your whole life in front of you, you start working there, and 30 years later, are you the same person? No. Because unbeknown to you, you've been divorced the person's been divorced 3 times, been bankrupt twice, has run up huge gambling debts, has a terrible drug abuse problem, and is now a perfect target for a bad actor to go and compromise them. You don't know that. Trust nobody. I know it's a terrible thing to say, and I know it won't sit comfortably with everybody, but challenge everything. Trust no one. Zero trust is where we need to be. So Jamie, that's about 40 minutes, and I see there's a couple of comments in the chat window. Okay, they're just from Jamie. Morning, everybody. Does anybody have any questions?
Let me just unmute, allow people to unmute themselves. So yeah, folks, you can unmute your line now if you want to throw a question.
Hi, Mark. Eamon here.
Hello, Eamon.
Do you think, contrary to sort of the past, should we say, where your security bods and your system programmers were quite clearly two separate roles, that they should start being merged now so that your security person has a bit of a sysprog hat on and your sysprog person has a bit of a security hat on?
I think the cross-pollination of the skills and the understanding is absolutely the right thing to do. Yeah, and we've often advocated, and Jamie and I have talked about this many times with lots of organisations, that role of the security engineer, somebody who gets security but also understands the technical challenges and bringing them together. But the security people explaining to the systems programmers why we do security, and the systems programmers explaining to the security folks how some of this works, yeah, is really important. And it's about that, it's about the collaboration. We are not, yeah, generally that communicative with each other. There are those separate islands, and what I'm advocating is we bring those closer together. Now, that might be a security engineer in the middle, yeah, being that conduit between the two teams, but absolutely they should be working together, sharing knowledge, yeah, understanding, yeah, what's going on in the business, what's going on in the real world. So yes, what I would say though is you don't want your systems programmer with RACF system special or ACF2 or top secret privileges. You don't want that. Yeah, but you want them to understand security, and you want the security guys to understand the systems programming bit.
Yes.
Yeah, I mean, for me, I know you've seen a lot of it as well, Mark, that I think some organisations have got themselves into a situation where, because of the kind of, you know, the sort of skill set in the security team, you often find like the system programming function compensating for that, so making security decisions when in reality, you know, it should be with the security team that are doing that. And it could be something simple like installing a product, and the system program says, right, run all these commands for me. That's not making security decisions. This is just about execute basically what I tell you to. Yeah. And I think that's a skills issue where, you know, the security team is not keeping up, you know, they haven't got the injection of skills that they need. But ultimately, if you had that, then I absolutely agree. I think it's like a partnership thing, isn't it? But you're in separate. You know.
I mean, and I know the focus on this session was, you know, the role of the modern day systems programmer, but you could absolutely just flip the title and say the role of the modern, yeah, mainframe security professional. Because just taking those set of commands from the systems programmer and just running them is absolutely not the right thing to do. You should go through them and look at them. What does that mean? What does that mean? And if there's something in there you don't understand as a security professional, doesn't matter. RACF, ACF2, top secret, it doesn't matter. You look and say, I don't know why we're doing that. I don't understand that. I don't think that's right. There are polite and professional ways to say no, or excuse me, can you explain this? Yeah. There's nothing wrong with that. And, you know, if people can't articulate why they want you to do something, you should absolutely not do it. Yeah? And if it needs to be escalated, you know, well, what's this going to do to our system? I don't know. Well, you should absolutely not be running those commands. If you can't explain it, yeah, then do not do it.
I was talking to a sysprog the other day, actually, and he said, I wish the security team would ask me or challenge me or ask me more questions, because he said he's like sort of at the point now, you know, where he wants to retire. And he says, I just wish people, you know, would ask, because I want to, you know, I want to share the knowledge and explain why things are done in a certain way to try and sort of, you know, help them along. And so, and I absolutely agree with this. You know, you should challenge, of course, from a security perspective, but you need to use and abuse these people as much as possible. You know, all these people with decades of knowledge, and extract what you can from them to, you know, even if they do seem like they're sort of leading from the sort of security side, it's, you know. Yeah. Any more questions for Mark? Because I'm going to ask a couple of questions.
Hello, Mark, it's Brett.
Hello, Brett.
How are you doing, mate? As ever, a fantastic presentation. Thank you very much. I wholly agree with your sentiment to never trust anybody. It's worked for me for a very long time, but you know, in this current climate, totally agree with that. I know we've chatted about this before, and I just want to bring the subject up again. That yes, the mainframe is one of the most resilient platforms on the planet, the most secure platforms available, but as you very well know, they will get in. They will get in. You know, you may not know. You might be lucky to know that they've got in, but you need to prepare for it. You know, people need to prepare for when they get in. It's a bit. I think of it like, you know, we all drive cars. Someday we're going to have an accident. You know, something unexpected is going to happen, and we'll have an accident in our car. And that's why we have car insurance, for the unexpected events. So I think people in the mainframe need to understand that hackers will get in, data will get destroyed, data will get compromised. Are you ready for that event? You know, that's the big challenge at the moment. It's I just find it very strange that we're in this weird situation in the last 5-10 years where the criminals are now getting locked down in other areas, and they're seeing the cyber crime as the new way to make shed loads of money.
Yeah, and Brett, it's a very good comment. And you know, if you look outside of the mainframe world and look at the wider security world, and you look at the kind of the leading experts, they actually talk now about, yeah, well, don't stop them getting in, because they're most likely already in. What you've got to do is detect them, find out what they're doing now. And that's where policies like zero trust and others, and real-time detection and real-time alerting all come to help us. Yeah, so they're going to be in. I like to ask the question, this is a bit of a sales pitch. I did a bit of a piece of work for a client a few months ago, and we were talking about DR, massive cyber, a massive international bank. And I said, have you tested your recovery procedures for DR? Traditional DR. And they went, well, what do you mean? I said, well, has anybody ever just walked into the machinery and flipped the switch? Turn it off. Yeah. How quickly can you recover? Oh my God, we could never do that. I said, so what do you actually test? Well, we publish a schedule that says at 5 o'clock on this day, we're going to shut the systems down cleanly. We're going to let the data finish replicating. We're going to cleanly IPL them. So are you telling me that the local airline who are going to crash the plane on your data center are going to tell you, Mark, at 2 o'clock next Friday, they're going to plane drop out of the sky and hit your building, so can you be prepared? It doesn't work like that. And the same thing for cyber resiliency. Yeah, yeah, it's a tumbleweed moment. How would you recover if you suffered a problem? Now, hopefully, we won't ever suffer. But it's true, you need an insurance policy, and we haven't got one at the moment. Yeah. And that's half the problem.
Cheers.
Yeah. So, Jamie, I've just got a couple of other slides here.
Go for it.
Okay. So, one, we want you all to become GSE members, those of you who are not. If you've liked all of the presentations throughout last week and this week, yeah, we are having a charitable collection for RNLI and the guide dogs. If you go to that link here, the Virgin Money, and you make a donation, you will get a receipt that gives you a receipt number. If you go to the GSE website, you can pop the receipt number in, the amount that you've sponsored, and you'll get entered into a draw. And we've got 150, 150 pound Amazon tickets, and we've got raffle prizes from Macro 4 and BMC. My favorite of all the prizes is a great big fat box of chocolate. Yeah, traditional old-fashioned chocolate. Okay, and then finally, feedback. This session is 1AZ. And finally, here are my contact details. If anybody wants to talk about any of this stuff, yeah, in a bit more detail, I'll be more than happy to help. Jamie, back to you. I reckon I'm pretty much on time.
You are, actually. We've got 10 minutes left, folks. Thank you so much, Mark. Excellent presentation. I mean, are there any more questions? Because I have a couple of sort of questions for Mark, just to get his opinion. But of course, the audience always takes priority. So any more questions? You can unmute your line, folks, if you want to ask a question. So while we're waiting for those, Mark, I mean, the thing about zero trust, and I really like it, but I often worry about the practicalities of sort of implementing it in a well-established mainframe shop. And one of the things that I really like, which I know is controversial, annoying, is this just-in-time privileges. And you hear a lot from big vendors like the Microsofts of this world that they say like about their cloud offerings that people cannot, it's just-in-time privilege, and you only have it for the period of when you really, really need it. I'm thinking, how practical is it for like thinking about the system programmer, and the accesses that they have? When all said and done, they do have privileged access. The people in the data center, security people. How really, practical do you think it is implementing something like that?
There's certainly technology out there, Jamie, to allow you to do that. But we've also got to understand there's a cost associated with security, and it's not always about money. Sometimes it's about process, and sometimes it's about time. Yeah. If I am the systems programmer and I need to go and make some updates to the system, and I have to go to an online system and go ba-da-da, 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 and it takes me a minute, and my access is provisioned automatically between the hours of 9 till 5 or 8 till 4, because that's the window we've said. We don't need authentication, but we just have to justify it, yeah, because it's logged and audited now, and it takes me a minute to do that. Is it really such an inconvenience, yeah, to protect you and your systems? I would say not. It's just a different way of working. Now, there's technology that says you can do that between 9 and 5. Outside of 5 till midnight, yeah, it's an email, or somebody has to click on a button, or if it's after midnight, then it actually needs a phone call. You can build all these processes in, because and also depending on the severity of the issue. Okay, all the online systems are down. If we build the tools and the processes properly, it shouldn't inconvenience people greatly to the point where they say this does not work. Okay, I've seen it done. I've seen some of the technology. Yeah, it does work, and it can work. We have to change the way that we look at this stuff. We have to change the way that we work. And just because I'm the systems programmer shouldn't give me access to everything all of the time. Because people can go and Google who's a systems programmer. What does a systems programmer do? What access do they typically have? They can then go on LinkedIn. Yeah, show me all the systems programmers that are out there. Oh, look, here's one that works for XYZ Bank. Spear phishing. We know it works. So there's got to be a trade-off between security and working practices, and I don't think what the businesses need from us, yeah, we should be getting in the way of that. They need us to be this diligent. We need to adopt that least privileged, role-based, zero trust type security frameworks. Otherwise, we're going to get caught.
Exactly, and I mean, I think that the thing I like about, I absolutely 100% agree with what you say, and the thing I like about the sort of the just-in-time, it's something that you just get used to, once you adopt it. But when you couple that with things like MFA, if you're not in the office and you're off on holiday for a week or something like that, and you don't have those privileges, better to have them off, because we still live in this sort of era of everything is always on, isn't it? Whether it's protocols or privileges, whatever it happens to be. And while they're on, it's just a path for someone to attack, and if it's off, then you can't. As simple as that.
It's a ticking time bomb.
Yeah.
Yeah, I mean, I'm working with a client at the moment where they've got 40,000 users in their security database that no longer work for the organization.
Yeah.
And they're there because they have a policy that says they will never reuse a user ID.
Right.
But the user IDs are sat in the security database. Now they've got no access, and they're revoked, and they're connected to a group that doesn't have access to anything. But it only takes somebody to compromise somebody on a help desk, and suddenly it's got a password, and suddenly it's connected to a few groups, or it's got a different ACF2 UID string, or it's got a few different cross-auths to top secret profiles. Get them out the database. Get them out. It's not where we store that information. Yeah.
No.
Just a different way of thinking.
Exactly. And the other point I wanted to pick you up on was around the sort of the hackers moving away from traditional methods. And when I saw, I mean, I've seen that, you know, like the whole GitHub thing, but it's like quite alarming now, isn't it? And I saw some famous names in there in that repository. You know, it's just unbelievable. And I heard something the other day about some stuff, open source hacking stuff for mainframe. And it's I think the people that we're having difficulty with, like convincing some of the stakeholders, and they see mainframe as very, very traditional. I think we have to get in front and say, no, 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 look at this stuff. You know, this stuff that you can apply in the cloud world, the distributed world, whatever you want the term you want to call it, is here for the mainframe. And you know, and they're not using traditional methods anymore. And if you use language like, you know, SSH or what, you know, those kind of things, I think it will resonate with them quite, you know. Yeah.
I mean, if you think about it practically, it's just a program.
Yes.
It's just a server, or it's just a bit of data. The
Yeah.
fact that it's sitting on a mainframe is really irrelevant these days.
Exactly.
Yeah.
Exactly. Okay, final opportunity, folks. Any questions for Mark? Any comments that you want to throw in? You can unmute your line. No? I will say one thing though, watch LinkedIn, folks. Next time you get solicited for a job, stand on your guard. Yeah, yeah. All right, Mark, thank you so much for that. It was, like I say, an excellent session, giving us a lot of food for thought. And I've certainly learned a few things from your session today, so thank you once again. So don't forget, folks, this is session 1AZ for the purpose of feedback. If you don't know how to get to feedback by now, you should go to the agenda, click on Mark's session, scroll right down to the bottom, you will see the link there. And as Mark said, don't forget our charity. I just actually had a quick look, and we're at 70% now, aren't we, of our target, which is fantastic. So yeah, if you haven't donated, do please consider giving a donation. We've got a break now from 11:30 until 12 o'clock. And up next on the security stream, and I know when you look at the agenda, if you haven't got widescreen, you might not see it, but we're actually moving rooms for the next session, which starts at 12 o'clock UK time. So if you scroll right across to the right, it's in the last room. It's a session from Broadcom, which is around zero trust from cloud to mainframe, how to get started. So hopefully you can join us for that. And of course, coming up as well, we have our usual lunch and learn session at 1 o'clock. So hopefully you can join us for that as well. But Mark, once again, thank you so much. And great to have you with us. And enjoy the rest of your day, everybody. Thank you.
Yeah. Thank you all. Cheers.
Thanks. Bye-bye.